Greetings, my beloved students. Welcome to the sixth video of the Alkanol series. I believe you must have been watching it from the first video we made on the series. Okay, I think this is the fifth video. Just make sure you follow it from first Alkanols 1 down to this one so that you'll be able to follow. Okay, now if you must understand very well, follow it from the first video on Alkanols, that's Alkanols 1 of the series. Now we'll talk about general properties of Alkanols. Like I said before, what I deal with in this channel is I deal with those areas students find challenging or where students have issues. They are the areas I take care of in sciences. I like to deal with. So I don't give you notes here. I teach you generally to understand it. Then if you go to your exercises, take wide questions, you can answer all of them. Do you understand? So that's the purpose. Okay, so look at this. General property of alkanols. Number one is that alkanols have high boiling points. All of them have high boiling points. All. Okay. The reason is because they have hydrogen bonding, and the hydrogen bonding is from the OH group, from the hydroxyl group. Okay, so because of the hydrogen bonding they possess due to the hydroxyl group, they have high boiling points. Now, I want to stress on this number 2, which is oxidation generally. Please, I will advise you to pay good attention to this one because it is a bit technical, so that I will try as much as I can to make it very simple for you to understand. Okay? Now, oxidation in chemistry. Anywhere you see this compound, KMnO4. KMnO4 is called potassium tetraoxomanganate 7. Take note of the name. Potassium tetraoxomanganate 7. That's the name. You can write it down. Or you see this one. This one is called potassium heptaoxodichromate 6. Okay, let me write it so that you can get it. This one is potassium heptaoxodichromate 6. Okay, this one is potassium tetraoxomanganate 7. Take note. Anywhere you see this one, this compound or this compound, know that oxidation is taking place. Are we clear? Once you see that you have this and this, know that oxidation is taking place in chemistry. Or rather, you can see something like this. 3 of them signify that oxidation is taking place. Please help me write them down. Very important. Now, let's proceed. All right. So, oxidation of alkanols generally, let's talk about them. Number one, oxidation of primary alkanols produces alkanals. Remember, the O changes to al, comma, and further oxidation produces alkanoic acids. Take note of this. Remember in the last video, I told you that anything one O is a primary alkanol. Remember that very well. So if you do oxidation of primary alkanols, you get alkanals. Then further oxidation will give you alkanoic acids. Let me explain. Now, let us have a general representation of this. ROH is a primary alkanol. Okay? If I write KNNO4 here, it means that oxidation is taking place. I've explained that one already. Now, if you do, this is a primary alkanol. Okay? Now, if this compound oxidizes this compound, that is oxidation, it forms an alkanal. Now, this is an alkanal. RCHO. Some students like to call it CHO. CHO. Okay, the CHO group. This is an alkanal. Okay, then further oxidation, that's KMN, we produce RCOOH. That COOH is an alkanoic acid. Are we good? That's an alkanoic acid. So a primary alkanol ROH undergoes oxidation to form an alkanal, and if an alkanal undergoes oxidation, it forms alkanoic acid. Now, I know the structure will look somehow to you, but I will explain it the way you understand it. We try to solve some examples so that you can digest the information. We may not finish it in this video, but let's ensure that the one we deal with, that you are okay. Then the remaining in next video we continue it. Now, structurally, you can write it like this: ROH. That's this one. Okay? With KMnO4, that's oxidation, forming RCHO. You do it like this. This is how you spread it. So you see this one now. The carbon to oxygen is a double bond. So that's how you write it. But if you want to use line structure like this, so it's either like this or like this. That is an alkanal. Okay? Then we now have KMn. This alkanoic acid will now be RC double bond single bond OH. Or I can do it like this. R C double bond single bond O H. They are the same thing. Take note. This one is a primary alkanol. This one is an alkanol. That's this one. Then this one is an alkanoic acid. Now let us solve examples. I just gave you the general formula, but by the time I solve some examples, you'll be able to understand it very well, and you can give some examples. Then also try to solve some questions from your textbooks. Okay, so this one is an alkanol, this is an alkanol, this one is an alkanoic acid. So please take note of that. Now let's solve some examples. You remember very well that let's do oxidation examples. Oxidation of ethanol. Ethanol is a primary alkanol. Now, let us look at the structure. In the first place, ethanol, if it undergoes oxidation, that is with KMnO4, remember that I can also use K2Cr2O7. Now, immediately you do an alkanol, immediately you do oxidation of an alkanol, you get this ethanol, the O changes to R. So we have ethanol. This is ethanol. So the O will change to R. Then if you do further oxidation, will form ethanoic acid. Look at that very well. So the O will change to R, and the R will change to oic. The O changes to R, and the R changes to oic. Now let's draw it. Ethanol is CC. I've taught you about O. So you put OH. I've taught you this one. This is O. Now, when it changes to ethanol, R will be like this. You do like this. 1, 2. This is et. You agree with me? This is et. Now, what is R? R means double bond O, single bond H. That is R. Double bond O, single bond H. So here we now have 1, 2. Then yes, here we now have 1, 2, 3. 2 hydrogen everywhere to make these bonds 1, 2, 3, 4. To complete it with 4. This is ethanol. Okay, so if you want to do an R, you put double bond O, single bond H with the 2 carbon atoms. Now, ethanoic acid, you do et. This is et. Now, oic means 1, 2 oxygen. Then we now have O and this is oic. This one has 1 carbon atom, so make it 4 by putting 3 hydrogen atoms there. This is the structure of ethanoic acid. Remember, oic means double bond O, single bond OH. Take note. Then R means double bond O and H. If you want to summarize it now, we have CH3, single C with 3 hydrogen atoms, then single bond C, 1 to H2, then OH. That is ethanol. Ethanol will now be C, H3, 1 to 3. See, this one will now be CHO. You write it as CHO. This CO, this HO, you call it as, you write it as CHO. Then this one will now be CH3, COOH. This one is ethanoic acid. This one is ethanol. This one is ethanol. All right, that is oxidation of ethanol. Now let me do one more example. Then I will ask you to try some by yourself. This one is oxidation of primary alkanols. Okay, so now let's take it further. Now let's do oxidation of propan-1-ol. Propan-1-ol. Let's talk about it. Now, propan-1-ol, if you do the oxidation, that's KMnO4, it changes to the ol will change to R, that's propanal. Are we good? Then further oxidation changes it to propanoic acid. So it's more like the other one we did. Ethanoic acid. This one is propan-1-ol or propanol. You can even call this one propanol. You can call it propanol. So the ol changes to R and the R changes to oic acid. All right. Now let's draw the structures. Prop is 1, 2, 3. So this is propan-1-ol or propanol. You now go further. You get propanal. How do we do propanal? What is prop? 3. This is prop. We now have R. R like I did before. Just do R like this. Then here put H. That's an R. Then this one has 2 bonds. You complete this one 4, 4. Remember I told you every carbon atom has 4 bonds. So this one has to fill 2 here to make it 4. Then fill this one. Put extra here. Put extra here. So that I can have 1, 2, 3, 4. Okay. This is propanal. Then further oxidation, KMn forms propanoic acid, which is this one. What is propanoic acid? C, 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 C. You now put the oic. I told you what oic is. Oic is double bond O, right? Single bond O, H. Then this one has 2 bonds. You put 1 here, 1 here. This one has 1. Put 1 here, 1 here, 1 here. You see that? That's propanoic acid. Now, how do we summarize it? This one will now be CH3, CH2. I believe you are conversant with this now. This one will be CH2, OH. Then here we have KMnO4. Here we have CH3, CH2. This one will be CHO. Remember I told you this O and H is CHO. Remember that. Then further oxidation. We now give us, this one is CH3, CH2. This OOH will now be COOH. Take note of that. It follows the same pattern. Okay, so these bonds, you can even put them here if you like. Don't like, don't put them. Now, you would help me do something after this video. Help me solve, or you can try it, oxidation of butanol, butan 1-ol, or simply you can call it butanol. You can try this on your own. You know, but means 4. You can even go as far as doing pentanol, that's 5, as case may be. That's pentan 1-ol. So try this one on your own and see if you can get it. Perhaps I'll do the correction in the next video. Okay, so we now go to, now we have talked about primary alkanols. Let's talk about secondary alkanols. Now, oxidation of secondary alkanols Now have a look at this. Oxidation of secondary alkanols produces alkanols. Nones. Okay. Now let me give you the formula. You know that secondary alkanols, I told you before, they are alkanols from 1-ol, from 2-ol and above. So we have okay, let's put it this way. Let's do some examples. Propan 2-ol. Propan 2-ol. If it undergoes oxidation, that's using chem and O4. You know that 2-ol means secondary alkanols. Remember that. Now, propan 2-ol, if it undergoes oxidation, it forms propan. Watch what happens now. The ol will change to on. It changes to on. Propan 2-on. So anytime you have 2-ol, it will change to 2-on. Okay? 2-ol changes to 2-on. Now we have, let's draw it. So this is 1, 2, 3. 2-ol means OH here. I've taught you this one. We now have this. If it undergoes oxidation, that's chem. Now let me show you how to do propan 2-on. You do propan 1, 2, 3. Now on, pay attention. On means put O on carbon number 2. The 2 is because we have 2 here. So on means put on carbon number what? 2. This O you are seeing here is what we call on. Now this one will now complete this one. Put H here. Put H here, making it 1, 2, 3, 4. This one has 1, 2, 3, 4. It is complete. It has 4 already. Don't put anything here again. Now here we have 1, 2, 3. This is propan 2-on. So why I didn't put anything here is because we have 1, 2, 3, 4. Remember I told you must have 4 carbon atoms around, and 4 hydrogen atoms around every carbon atom. Now the summary will now be here. We have CH3, CH, OH. You can put this bond if you like. You can put this bond if you like. Don't put it. You see the same thing. So if I want to put, I can do this, and I can put this one. If you like, don't put it. It's not by force. We now have KMN oxidation, take note, it will now form CH3, C double bond O, CH3. Because of these 3 hydrogen atoms here, this is propan 2O. Take note of that. Okay, so this is what we call oxidation of secondary alkanols. How do you know secondary alkanols? 2 or more than 1. Then every secondary alkanol will change to alkanol. That is 2-O. Take note of that. Okay. Then finally on oxidation. Okay, maybe we can take. Let's take another example on this. Let's take another example on this one so that you can digest it. Let us do pentan 3-or. Pentan 3-or. Let us do it. If you oxidize it, remember that it is a secondary alkanol because it's not 1-or. It will form pentan 3-one. Pentan 3-one. So the ol will change to one. Are we good? Now let's draw pentan 3-or. C, 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 C. So 1, 2, 3. I put the ol at number 3. I've taught you this one. Okay? So now H, 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 H. This is one I've taught you already, pentan 3-or. Now it will change to pentan 3-O. How do we do that? 1, 1, 2, 3, 4, 5. Are we together? The 3-O now means on the third carbon atom, 1, 2, 3. You put your O. I told you that this O means O. Don't forget. So here you now complete this. 1, 2, 3. That's 1, 2, 3. That's 4 now. This one has 1, 2. You put 1, 2. That's 2. This one has 1, 2, 3, 4. It's complete. Don't put any other one. 4 is maximum. This one has 1, 2. So you put 1, 2. This one now has 1, 2, 3. That is pentan 3-O. Take note of that. Then to summarize it, we have CH3, CH2, CHOH, CH2. I believe you understand this, but I've taught you this already. Now here we have CH3, CH2, C double bond O, CH2, and that's pentan 3-O. So please, if it is 2,3-ol, it becomes 3-ohm. If it's 4-ol, it becomes 4-ohm. As case may be. Take note of that. Now, you can also try some in your textbooks. Then finally, tertiary alkanols do not undergo oxidation. Tertiary alkanols do not what? Undergo oxidation. How do you know a tertiary alkanol? I explained it in last video. So please, I believe you listened to it very well. So they don't undergo oxidation. So if I do something like 2-methyl propan 2-ol, this is a tertiary alkanol. That reminds me, a tertiary alkanol, how you know it basically, in fact, you see the number of the branch is the same thing as number of the ol. 2-methyl, 2-ol, 2-methyl, this is a tertiary alkanol. Are we good? 2-methyl 2-ol is a tertiary alkanol. The numbers will be the same thing. If I clean this 2-methyl now, it becomes propan 2-ol. It becomes a secondary alkanol. If I attach this 2-methyl now, meaning that this and this are the same, it becomes tertiary. Take note of what I said now. If I close this, it becomes ordinary propan 2-ol, which is secondary alkanol. If I open it now, it means there's a branch on it, whose number is the same thing as number of the ol. That's a tertiary alkanol. Take note of that. So if it undergoes oxidation, remember I said this KMNO4 is oxidation. The answer is no product. So there's no product. Then the same thing happens here. The same thing happens here. 3-methyl. Okay, let me use chloro now. 3-chloro pentan 3-ol. You see, 3-3 now. That's a tertiary alkanol. So if you undergoes oxidation, the answer is no product. So in this video we have talked about two properties of alkanols, which is boiling points, that they have high boiling points because of because of the hydrogen bonding due to the hydroxy group they have. Now we've talked about oxidation of the 3 types of alkanols. Remember what I said? Primary alkanols undergo oxidation to form alkanes and alkanoic acids. Secondary alkanols undergo oxidation to form alkanoids. Tertiary alkanols do not undergo oxidation. I've explained it now. So I believe you can identify a primary alkanol if you see secondary and tertiary. Okay. So that's the end of this video. Please help us. If you're on YouTube, just subscribe, press the subscribe button, and then turn on the notification so that if you post the next video for this, you will be notified. Okay. Thank you very much for coming around. God bless you.